Hey everyone, this is Lucas Wilkerson, and I'm the math coach here at FGCU. I'm going to be working through section 4.1, 4.2, 4.3, and answer a couple questions. And then also, if you want to come to the review session, see all these problems worked out, you can show up for that Tuesdays, 4:30 to 6. Should be library 464. So let's get started. Looking at question 1, it says graph the function by making a table of coordinates. So when it says make a table of coordinates, it literally just means like plug in a number and test that. So here, let's see, I'll just make a list. Plug in for x, we'll do -2, -1, 0, 1, and 2. Those are always a pretty good set of numbers to test if you're just going to guess and test. So if we plug in -2, our exponent becomes -2, which can also be written by just flipping these and taking the regular square. Gives us 25/9, which is roughly 2.8. Plugging in -1, we get this. Again, we can just flip it, change the negative, and we get 5/3, which is roughly 1.7. We can plug in 0, and anything raised to the 0 power is just equal to 1. We can plug in 1, which leaves us with just 3/5, which is roughly 0.6. Plug in 2, gives us 9/25, which is roughly 0.36. Then we just have to look at graph A, B, C, and D. If we go to plot the points, we see it's not A, going in the completely wrong direction. B has negative answers, so it can't be that. D also has negative answers, and if you went through and plotted some of these points, you would see the answer is C. Moving on to the next problems, looking at 4 and 5, it says use the compound interest formulas to solve these problems. So the trick with the compound interest formulas is, let me get my highlighter out. This one that I'm shading in green, you're going to use when you have compound quarterly. And this part formula, you're going to use when you have compound continuously. So let's look at our problems. Find the accumulated value of an investment of $500 at 8% compound quarterly for 4 years. And here we see we have compound quarterly. So because of that, we know we're going to use A equals P, just like this. And then we need to plug in the information that they give us. They give us that the investment is $500, so that's going to be P. It's at a rate of 8%, so that's going to be our R. Make sure we convert it to decimal. Since it says quarterly, our number is going to be 4. It's every quarter. And then the time is just 4 years. So if we plug that in, it's going to look something like this. And 4 times 4. And that equals roughly $686.39. Make sure since you're working with dollars, you round it correctly. Then for number 5, it says find the accumulated value of an investment at $3,000 at 7% compound continuously for 5 years. So here we have that compound continuously. So we know we're going to use, I like to call it the PERT formula. This is going to be our P, the 3,000. Our R is 0.07. And that T is going to be 5. And we're not looking for anything for E. If you actually look on your calculator, you'll see there's an E button. It's like pi. It already has a certain value. So this becomes 3,000 E 0.07 times 5. Plug that into your calculator and you get roughly $4,257.20. Moving on to the next section, 4.2, we're working with some logarithms. And for question 1, it says write the equation in its equivalent exponential form. So basically, it wants us to write it how it would normally look without a log. And the trick to that is whatever the lower number of the log is, you kind of just need to move it over here and then move the 3 on top of the x. If that's confusing, well, actually, maybe that's confusing because it's the incorrect way to think about it. You actually want to move the 3 to the exponent of 2, and then like move the 2. And actually, don't move the 2. You know what I'm going to do? I'm just going to show you what it is. It's going to be 2 cubed is equal to x. And so we leave this x where it is, and then we just bring the 3 on top of the 2. All we're doing is sort of reshuffling it. For number 3, it says write the equation in the logarithmic form. So we're doing the opposite of what we just did. This can be rewritten to look a little nicer. That third root is just being raised to the 1/3 power. And then we can just do some rearranging. We're going to take the log, and we need to move our big number right there into the lower part of the log. It's going to be log 343. And then the 7 will come over. Log 3437 equals 1/3. And if you're looking at this and you're like, is there a step I'm missing? What's going on? Why am I moving things around like this? These are just the basic like logarithmic rules that allow us to move it like this. So it's supposed to look new and probably feel a little weird the first couple of times you see it. Sorry, allergies. For number 5, it says evaluate the expression without using a calculator. So let's see, how do we want to approach this one? Simplest way to do this would be to move the 729 to the other side. So it'd be like 9 raised to what is equal to 729. It's almost as if there was like an equal x there, and that was the x. So looking at this, we can't use our calculator, but we know it's going to be a regular whole number. If you test out 9 times 9, you're going to get something like 81, so you know it's not that. But if you do 9 times 9 times 9, you can see you would get this 729. So it's going to be 9 cubed is equal to 729. Then for number 7, it says evaluate the expression without using a calculator. So doing the same thing that we have here. So we'll just rewrite this similar to the previous one. We'll say 25 raised to what equals 5. And the way we can think about this is since 25 is bigger than 5, we know we're going to raise it to a fraction. And this would be like taking the square root of 25 would give us 5. So we'd say 25 raised to the 1/2 power equals 5. Looking at number 11, it can look a little weird because there's not that like little log number. And the thing to remember is if they don't give us one, we assume that there's a 10. So anytime, like you see here, they make it 9, here they make it 5, here they make it 3. If they don't do that for you, the rule is just you assume it's a 10. So doing the same thing, we take this 10 out and it's raised to what to equal 10,000. And this one's a little easier to observe. We just add 3 more zeros, and so it would be 10 cubed. Let's see. Number 15 says find the domain of the logarithmic function. So we're going to find the domain of a logarithmic function. The way to think about this, is to look on the inside piece and set it greater than 0. So for us, that would be 2x plus 8 greater than 0. Let's get x by itself, subtract 8 from both sides, divide positive 2 from both sides, and we get x is greater than negative 4. If your professor needs interval notation, that's going to look like starting at negative 4 and all the greater values going into infinity. Moving on to section 4.3, says we need to use the properties of the logarithms to expand the expression as much as possible. Where possible, evaluate the logarithmic expressions without using a calculator. So that's just a handful of things to say, use the logarithmic properties to expand these. So at this point, you're probably asking, what are the logarithmic properties? And I will give them. They're going to be, if you have the log of b in x raised to the a, you can change that to a log b of x. These are just ways to rearrange things, but they're pretty helpful tips. Then if you have the log of b, x times y, you can split that into like 2 pieces. So the log of bx plus, you guessed it, the log of by. If you have the log of b x over y, you can change it to the log of b x minus the log of by. So now that we have these in place, we can just reference these 3 little rules. I'll call them like 1, 2, 3. We can reference those and help us expand. So looking at question 1, we see they're being multiplied in the parentheses. So we're going to want to use rule number 1, and we're going to want to split these up. So this would turn into the log of by plus the log of bc to the 9th. And that 9 we can actually move down. So it's 9 log bz. Now for number 4, we have a log 3 with the square root of x over 27. We can change this by using rule number 3 into the log 3x 1/2 minus the log 3/27. We can move the 1/2 to the other side, like this. And then this piece right here that doesn't have an x, we could change that to 3 raised to what equals 27. Did some guessing and testing, you would see 3 cubed is equal to 27. So our final answer would be 1/2 log 3x minus 3. Looking at number 5, we have the log of b and that crazy fraction. So we're going to need to use rule number 3 to divide this up a little bit. So this is going to change into the log of b, the log of b, x plus 1 to the 9th, minus, in the denominator, log of by, minus the log of b z raised to the 8th. And as shown previously, we can take these exponents and just multiply them by the log. So we can simplify it to 9 log b x plus 1 minus log by minus 8 log bz. That would be your final answer for this one. And for number 7, it says use the properties of logarithms to condense the logarithmic expression. Write the expression as a single logarithm whose coefficient is 1, and where possible, evaluate the logarithmic expression. So let's take a look at this problem. We're kind of just working backwards. So since they're being added together, I'm guessing we're going to move towards bringing them inside and multiplying. But we're going to move some things around. Let's see. We'll want to bring the 3 back into the exponent so we can resort it. So it'll become log x 4 cubed plus, we don't really need to change this, log x 2. And then log x2 just turns into 2 if you solve it. Oh, no. That's incorrect. We can't solve it because it has an x in it. But if we want to bring them together, we can go log x in the parentheses 4 cubed times 2. Just again applying rule number 2, but using it to bring it into multiplication. And then if you multiply that out, you would have log x 128. And then let's also look at number 8. Number 8, we'll do a similar thing. We'll bring both of these into the exponents. We'll get the natural log of x to the 6 minus the natural log of y to the 1/3. And natural log is just another type of logarithm. And then since they're being subtracted, we'll just change them into a fraction. X to the 6 and then y to the 1/3. And that would be that.